Hi, welcome. This is a similar question to our notes, so I would suggest using your notes and any of the questions 1A, 1B, or 1C to kind of answer this question. Okay, so the measure of angle R, here's angle R. They said angle R is 37. So we notice that angle R is an inscribed angle. Inscribed. It's the tip of the cone. If it's on the circle, it's a tip of a cone, and we know the tip of the cone is half the snow. So we know that the snow is 74. And now this makes us think of our pizza, doesn't it? This is a slice of pizza. So if you wanted 74 degrees of super yummy cheesy crust, the angle in the middle of the circle would be 74 degrees. Those numbers should be the same. The central angle is the same as the arc measurement. The inscribed angle is half. Okay, so I'm going to put my answer here for angle O is 74. I'm going to put it in my answer bank. Bam. Cool. Now, using that same basic concept, and how would it get a lot more complicated? So, same here. Got some snow, right? The tip of this cone is 48, so I can do the same methodology. 96. Using that same concept, if I want 96 degrees of super yummy cheesy crust, that means the angle at the center would be 96 as well. So angle 2 has to be 96. Okay. We also noticed, well, wait a minute. Angle 2 and 3 make a straight line. So angle 2 and angle 3 are a linear pair. So if that's 96 here, that's going to have to be 180. Also, the other way to think about it is if this is in fact the diameter, this semicircle is 180 and the angle at the center has to be 180. So diameters make 180 degree angles. They're straight lines. They go through the center. So I'm going to take 180 minus 96 and I get 84. Okay, so 84 and 96 make a straight line. So now I know angle 3 is 84. Okay. It's kind of hard to see that, but okay. Angle 3 is 84. Now I got the same situation. The center of a pizza slice, if that's 84, then that means that this crust would have to be 84 degrees of crust. The center of the pizza, 84, the crust, 84. But now I see an inscribed angle. Angle 4 is inscribed, so the tip of this cone, it's on the circle, has to be half of that. So half of 84 would be 42. So angle 4 would have to be 42. Okay. So if angle 4 is 42, I can double check my answer here. 42 and 48 better be 90, and it is. So that always happens when I have an inscribed angle that's made with the diameter, because notice the semicircle 180 and half of 180 would be 90. So there's a couple ways to do this question, but that would just be one way. So that's definitely 42 degrees. And now I notice angle 1, I actually know the snow created by the inscribed angle at angle 1. So, oh my gosh, this thing's turning into a rainbow. Here we go. So angle 1 has this green snow. So if angle 1 snow is 96, going backwards again, that would have to be 48. So the tip of the snow, 48, is half. The tip of the cone, 48, is half of the snow, 96. So angle 1 is 48. Okay. There we go. Pretty neat. Now we look again at some angles. We've got some angles here, lots of angles happening on the circle. None really happening in the circle, so this is a slightly different problem. And it says the measure of arc AD. So the measure of arc AD, we could also, instead of the word arc, just make a symbol, is 91 degrees. Okay, so that's 91 degrees. Now they also are telling us angle D. Okay. Angle D is 100. Okay. They'd like me to figure out angle DCQ. DCQ. So notice angle DCQ. C is the vertex, and it is on the edge of the circle. So believe it or not, the tip of that cone, even though it's all squished, the tip of this pink angle right here, the tip of that cone has to be half of that green snow, because that really is the arc that's formed from that angle. So if I know the green snow, I can work backwards and find that. And I think I can do that here. So if I look at this angle 100, I know the tip of one cone, so I have to look at the arc that's created from that inscribed angle. So it looks like this big orange snow. That's how much snow is created by this big snow cone. So the orange arc here, whoop, really big, that's a major arc. That would be 200 degrees because the tip of the cone has to be half the snow. So I know the orange arc is 200, this one's 91, so see how I really can figure out this green arc. It's just what's left over from all the way around 360. So 360, take away the orange one, okay, that'd be 160, and then take away this pink one, and I'm left with 70. So I actually know that that snow has to be 70, which means the tip of the cone has to be 35. So the angle does look pretty small. The tip of the cone 35 is half the snow. The green snow is 70. Oops, I think I did some math wrong there. 91. So it was off by 1, so that'd be 69. Sorry about that. So this snow is 69. Okay, now let's just double. Gotta be. And then I make a math mistake, I think. Oh, I better double check that. So let's just make sure I got this. All the snow, 200, plus 91, all the arcs, plus 69. Yep, is 360. Now I'm good. Now working backwards, what's the tip of the cone? So I gotta take 69 divided by 2. And I get pretty close to 35, 34.5. Okay, so let me switch that up. So that's all they're asking here. They're asking what is the angle at CDCQ? It's 34.5. Bam. All right, next question. This one's a doozy. I really like this question, but it is a little technical. So back when we did tangents, the basic idea, and I'm going to draw a circle here. The basic idea is if I have a tangent line and a tangent line, I call those party hats. Tangent lines make 90 degrees with the radius. So what we end up finding out using the concepts of congruent triangles is that the radiuses are equal, and that's equal because of reflexive. And so hypotenuse and a leg is a match, a hypotenuse and a leg is a match, yada, yada, yada. Corresponding parts tell us that this side and this side have to be equal. So if I think of this as a party hat, the left side and the right side have to be equal of the party hat. And I have the same thing going on here. If the left side of this party hat is X, the right side has to be X. But I don't know the rest of the information, so I kind of have to draw that in. Okay, so let's take a look. It says the pentagon, so they're actually thinking about this pentagon, has a circle stuck inside, and that's what circumscribed means. Circumscribed means I take a shape like a pentagon, a 5-sided, and stick a circle inside. And what gets created is a lot of tangent lines. So we know X and X. We also know RS is 10. So you think about the whole length RS, that's a side of my pentagon, that's 10. So thinking mathematically here, if X was 4, I'd know that's 6. So I think what mathematically happened in my brain was I subtracted. I took 10 minus whatever X is. So I don't really know what this length is, this other party hat. So you should think of these as different party hats. They all might be slightly the same size, and you could think of putting the party hats on a basketball. 5 different size party hats you put on a basketball. But what you do know is the left and the right side of each party hat has to be the same. So whatever that is, again, if x is 2, I know that would have to be 8. So in my brain, I'm taking 10, subtract whatever x is. Well, now you've got some information for this side of the party hat, don't you? If I know that that's 10 minus x, this side has to be 10 minus x. Pretty neat, right? Okay, so let's look at what ST is. They told me ST happens to be 13. So this is where it gets a little sticky. I know that this is 13. And if this again was 3, I'd know that's 10. Or if this was 4, I'd know that's 9. Or if this was 6, I'd know that's 7. So I want to do I know this length here. This length here is just the whole thing minus the part would give me the other part. So it's 13 minus 10 minus x. That will tell me this orange part. It's just 13 minus whatever that is will tell me what's left. Well, using a little algebra here, 13 minus 10, and then minus a minus would be plus, I can actually use a little algebra and make the problem easier. I know it's just x plus 3. Cool, x plus 3. And if that side's x plus 3, this side should be x plus 3. Because again, that's a party hat. The left and the right should be the same. So the left and the right of this should be the same. And I'm going to have to pick up where I left off in the next video.